Hello, thank you all for joining us. My name is Louay Eldada. I'm the CEO and co-founder of Quanergy. We make 3D sensors and the software that go with them. The 3D sensor is LIDAR. I think at this point we can pretty much say the word LIDAR without having to explain every time what it means. 3D laser-based sensor. As it's shaping up and more people are on board with the idea that for the autonomous vehicle revolution to happen, you must have LIDAR. If you disagree with me, let's have a talk, but maybe by the end of my talk, there will be less disagreement. We're about 5 years old. However, the technology is about 30 years old. I did this for my PhD 30 years ago at Columbia for DARPA, and now we are making it into a product. A bit of history about our funding. Everybody knows we're a unicorn. They make a big deal out of this. But the key thing is that we have the most advanced technology, the only LIDAR, and I'm challenging everyone here, the only LIDAR that meets performance, reliability, and cost criteria on the market. And when I say reliability, I mean the highest level of reliability. It's a true solid-state LIDAR. We're not talking micro-MEMS mirrors or oscillating mirrors or spinning lenses or anything like that. We have almost 200 employees. We have received many awards. Pretty much any big award in the space was awarded to us. And when I say awarded to us, it means we placed #1. We were the winner in all of these awards. So there's a new paradigm in 3D sensing because there has been lots of development in a number of areas. Certainly low cost, high performance, solid state LIDAR, but also low cost, high compute power, advanced processors, as well as very advanced artificial intelligence software. So those capabilities which have matured at the same time now come together to create very capable systems that support smart solutions, autonomous vehicles, smart cities. You could broadly call it the smart IoT. Quanergy as a company started with the goal to support autonomous vehicles, and that remains our main mission. We do support other spaces as well, however. We support the security space, broadly defined. It includes the smart cities, smart buildings, all the way to smart perimeters and so on. Industrial automation, as well as 3D mapping. In reality, we have 4 big areas. We call them pillars that include about 40 industries that support about 400 applications. Those are some of the applications. I don't have to read through them. You can see them. The key thing is that the LIDARs that go into these systems, these solutions, they lead in all of cost, performance, reliability, size, weight, and power consumption. We are running live demos for the whole show in the booth of Sensata, our partner, which is back here in the B aisle. If you're a customer or a partner or someone who has genuine interest to use the product, we'll take you and we'll show you the live demo, and you will see what we're talking about. Of course, we could spend 2 hours just going through this matrix. It compares LIDAR with camera with radar. Simply put, LIDAR is a 3D sensor, camera is a 2D sensor, radar is a 1D sensor. No one can argue with that. So that alone, I should be able to stop right here, but when you add the significantly higher resolution, when you add the fact that you can maintain high resolution in long range, when you add all of these capabilities, and when you're comparing LIDAR, video, and radar, it's no contest. Having said that, you need all 3. We used color from camera, also the OCR to read signage. We use radar. You need redundancy. So radar is the other very capable long-range obstacle detection sensor. Well, I think we're beyond the point where we have to show the Google car and say this was the past, and no one is going to buy a car that has a big, spinning thing on top, or a bunch of them, as we have seen recently. The LiDAR I'm talking about, the solid-state LiDAR, is hidden inside the vehicle. It's integrated in the body of the vehicle. You're never going to see it. In this red Mercedes-Benz, which was given to us by our partners at Daimler, we have two solid-state LiDAR sensors completely confined inside the body of the vehicle, hidden behind this black fascia, which is IR transparent, and it was custom designed for us by our partners at Delphi. You can read the comparison basically in every aspect. One of them is a production solution. The other is a pilot development, maybe software development, temporary solution. Just to show you one example of something really unique and cool that you can do with solid-state LiDAR that's just impossible to do with other LiDAR. Here you see that we work with our friends at Koito. Koito is actually, it's a tier 1. It's the largest headlight manufacturer in the world, and we work with them to integrate two of our compact solid-state LiDARs inside a headlight. We showed this at CES, and we're showing a more advanced model at the next CES. And here you see there's one LiDAR that points forward, one LiDAR that points to the side. By having both front headlights configured that way, you can see forward with some overlap, and you can see to the side. And that's all you need. In the back, you don't need a LiDAR. In the back, you can have, in reality, a low-end radar just to know that something is approaching. First, we did develop a mechanical LiDAR. It's easy to develop, allowed us to develop software. It has its own merit. Having said that, we have the most advanced, the highest performance, highest reliability mechanical LiDAR you can buy. We call it the M8. But really, our core technology is the solid-state LiDAR. And for the automotive space, we are commercializing this capability, this solution, with our partners at Sensata. We have a couple of different form factors. Long term, we have the capability. By design, when we started the company, every component we have for emitting, for receiving, for processing is based on silicon CMOS, because our intent has been all along to bring all the chips together onto a single substrate, to integrate them on a single substrate, and have a single chip LiDAR that you can integrate in a cell phone. But this is going to be a really high-end LiDAR. This is not like what you see in some cell phones. This works outdoors, long range. You can be outdoors at an archaeological site, and you can go, map the whole structure. This is a really high-end LiDAR. It can go in the helmet of a firefighter or a soldier, and it can go inside every thermostat, appliance, so on and so forth. It's going to make LiDAR really ubiquitous. We have, by the way, our core solid-state LiDAR patent has already been granted, and we have many more. In terms of the capability of the solid-state LiDAR, you can do things that you cannot do with the LiDAR that relies on mechanical motion, whether it's macro spinning, macro oscillating, micro oscillating. You cannot do this because they all rely on motion. Here, we have random access because we're not physically moving between two directions. We have zoom in, zoom out capability by changing the phases of the optical phase array, which I'm going to talk about. You have the highest reliability. It's truly solid state. We guarantee over 100,000 hours of operation as MTBF. And by software, you can modify the frame rate, modify the point density, the window size, so on and so forth. As probably everyone knows by now, our technology, we're the only ones commercializing and producing the solid-state LiDAR that's based on the optical phased array. It's basically similar to the phased array radar in the optical domain, so everything's 10,000 times smaller. Everything scales with the wavelength. So our chip ends up being essentially less than 5 by 5 millimeter chip, and it does beam forming and steering by changing the phase values in an array that might have a certain size, say 1,000 by 1,000 pixels. This shows the different chips that we have inside the solid-state LiDAR. On the emitter side, we have the optical phase array and the control chip. On the receiver side, we have a SPAD array and an ROIC, a readout IC for TDC measurements. And we have a processor, one inside the sensor, and then one central processor, one advanced central processor for the entire system that does perception on the combined point cloud that you get from multiple LiDARs plus radar and camera. You take now input from a number of sensors, and this is an infographic that was done by Delphi. It shows in purple a quantity LiDAR. It shows cameras in red, radar in yellow. Each OEM has their own preference in terms of how many of each sensor they use. But the key thing is that the LiDAR is the primary sensor, which means it's the one sensor used for perception, for localization, and for navigation. Data from multiple sensors, from IMU and GNS, from vehicle data, as well as context data, all comes in our central processor. We run our perception software, and out comes an object list. Some examples of imagery collected with our LiDAR, just to give you examples. This is right outside our headquarters in Sunnyvale. This is actually collected from a drone. Key thing is that these 3D maps, if you will, were collected in real time, no post-processing, single pass. This was collected with a drone in Korea. This was collected by LIDAR USA here in the US. You can see the resolution. And for the last slide, I'm going to show some of our partners, with our main partner for commercialization in the automotive space being Sensata. We have a number of OEM, Tier 1, processor, and mapping partners, as well as fleet partners. Of course, we have a lot more partners, but those are the ones that gave us permission to mention their name publicly. We have 10 offices globally. We are hiring a lot. So if this is something that excites you, please send us your resume. That's all I have. Thank you.